The topic to be explained here is ultrasonic sensor HCSR04. Generally, ultrasonic sensor is a sensor that can measure a distance. It emits an ultrasound at 40 kHz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the travel time, speed of the sound, you can calculate distance. This is the ultrasonic sensor. This one is transmitter. This one is receiver. This ultrasonic sensor is used to measure the distance. It emits an ultrasonic waves at a frequency of 40 kHz, which travels through the air with a velocity is equal to 340 meters per second. And any obstacle is there. If there is an object or obstacle on its path, it will bounce back to the ultrasonic sensor. Considering the travel time and the speed of the sound in air, you can calculate distance. We know that distance is equal to two-way distance. This is the original wave. Transmitter send the original wave, yellow color here, yellow color. An object is there at a distance R, capital R, from the sensor, ultrasonic sensor. Some reflected wave bounce back and reach to a receiver of the ultrasonic sensor. Find out the distance between this ultrasonic sensor and obstacle. We know that velocity is equal to distance by time. Distance is equal to velocity of the sound v into time small t. Two-way distance from transmitter to obstacle and obstacle to receiver. Two-way distance, that is equal to 2r, is equal to velocity into time. That is equal to r is equal to velocity of the sound wave in the air v into t by 2. T by 2. This is the distance measurement case of ultrasonic sensors. Velocity of the sound in air is v is equal to 340 meters per second. Coming to pinout structure, this is the ultrasonic sensor. The sensor has 4 pins. These pins are VCC, trigger, and echo, ground pins. This one is VCC, trigger, echo, and ground pins. VCC and ground to VCC is connected to 5 volts of the Ardunio board. 5 volts. And trigger and echo, these two pins are connected to any digital pins of the Ardunio board. Any digital pins of the Ardunio board. 2 to 13 pins are there, digital pins. Digital pins of Ardunio board. Ground is connected to ground of the Ardunio. Generally, the sensor has 4 pins: VCC, ground, and trigger pin and echo pin. VCC is connected to 5 volts of the Ardunio, and ground is connected to ground pin of the Ardunio. And trigger and echo go to any digital Ardunio pins from 2 to 13. Using the trigger pin, we send the ultrasonic waves from the transmitter, and with the echo pin, we listen for the reflected signal. By using a trigger pin, we send the ultrasonic waves. We send the ultrasonic waves like that from the transmitter by using trigger pin. And with the echo pin, this one is echo pin, we listen for the reflected signal. This is the transmitted signal, TX signal. This one is the reflected signal. Reflected signal. Here some object is there here. This one is the object. Okay, next coming to ultrasonic HC SR OR module timing diagram. In order to generate ultrasound, we need to set the trigger pin on high state for 10 microseconds. Initially, here some low value is there. Triggering pin is at low value. That means trigger pin is at clear state. Clear state. In order to generate ultrasound waves, we need to set the trigger pin on a high state for 10 microseconds. This is the trigger pin is on at high state. The duration is 10 microseconds. The trigger pin is set high state. The duration is 10 microseconds. Then ultrasonic sensor generates some sound waves that will send out an 8-cycle ultrasonic burst which will travel at the speed of sound. Whenever the triggering pin comes from high to low value, this is the low value, 840 kHz sound waves generated from HCSR04. That means not O, 04 is ultrasonic sensor generates these 8 cycles that will send out an 8-cycle ultrasonic. This is the ultrasonic burst. This one is the ultrasonic burst which will travel at the speed of sound. Speed of sound is 340 meters per second. After that, last 8 pulse, the echo signal pulse is the echo pin goes to high right away after the 8-cycle ultrasonic burst is sent. After that, echo pin is set to high. Echo pin is set to high. During that time period, time taken by pulse to travel to time taken by pulse to leave and return back. During that period, an echo signal. This one is a echo signal. Echo signal return back to ultrasonic sensor. Initially, the trigger pin is at a clear state. In order to generate ultrasound waves, the trigger pin is set to high state. The duration of that pulse is 10 microseconds. After that, after the trigger pin is low value, this is the trigger pin is at low value, that will send out an 8-cycle ultrasonic burst. This one consists of 8-cycle ultrasonic burst, which will travel at a speed of sound 340 meters per second. 840 kHz sound wave generated from ultrasonic sensor. The echo pin goes high right away after that 8-cycle ultrasonic burst is sent. After 8-cycle ultrasonic burst is sent, the echo signal is set to high state. And it starts listening or waiting for the wave to be reflected from an object. During that period, here some object is there. Here some object is there. This one is the object. Sound waves are incident and some reflected waves are bounced back and reach to ultrasonic sensor during that period only. These are the pin diagrams of that pin diagram of that ultrasonic sensor. Coming to explanation, this is the sketch. Generally, here we use a combination of ultrasonic sensor plus LCD display plus serial monitor. Serial monitor display. Ultrasonic sensor has 4 pins. LCD has 16 pins. This serial monitor used to indicate the distance between the ultrasonic sensor and an object serially. With the help of that functions, I have to see that display the distance between the object and the ultrasonic sensor. This one LCD is the 16x2 display, 16 columns and 2 rows. Now in that code, this is the actual diagram. This one is LCD. This one is ultrasonic sensor. Now I will concentrate on code. First library. This one is the library. Library of the LCD crystal. Slash include less than liquid crystal dot h greater than. Next liquid crystal LCD 13, 12, 11, 10, 9, 8 are the digital pins of the Arduino board. Digital pins of the Arduino board. Here 13 is connected to RS, register select pin of the LCD, and 12th pin of the Arduino board is connected to enable, and 10, 11, 10, 9, 8 pins of that Arduino, digital pins of that Arduino board is connected to data pins D4, D5, D6 and D7 pins of the LCD. This is the meaning of that. You have to make a connection between the LCD and Arduino board. Next one is ultrasonic sensors as 4 pins, VCC, trigger pin, and echo pin, ground pin. VCC is connected to 5 volts of the Arduino board. Ground is connected to ground of the Arduino board. Trigger pin is assigned to one of the digital pin of the Arduino board, that is 2. Trigger pin is assigned to 2, and echo pin is assigned to 3. These are the 2 digital pins of the Arduino board is assigned to trigger pin and the echo pin of the ultrasonic sensor. Declaration: constant, some integer. Next one, duration. This is the duration. The trigger pin is at high condition. During that period only, within that period only, an echo signal bounce back to ultrasonic sensor. This is the duration. The duration is a long duration. Assign long to duration. Next one, distance between our main aim of that ultrasonic sensor is whenever an object is there at a distance r from the ultrasonic sensor, find out that r distance in centimeters and in inches. Integer distance in centimeters, integer distance in inches. These 2 parameters are also declared. In the void setup, here we use LCD 16x2 LCD used to, this one is LCD used to display this distance, centimeters and inches. Now in the void setup, LCD is clear, initially clear the LCD. LCD begin with 16 comma 2 means 16 columns and 2 rows. And also serial monitor. Serial monitor functions are also indicated here. Serial dot begin at this baud rate is 9600 because serial monitor is also used to display the distance in centimeters and the distance in inches. Combination of these two. Both are incorporated with this code. Pin mode here, trigger pin. Trigger is this one is the trigger pin is the output pin because output pin of that why it is output, the ultrasonic sensor send some signal to objects towards the object, that is called as this trigger pin is output, and some signal is come back to echo signal is come back to bounce back to and reach to ultrasonic sensor and collected by the receiver of the ultrasonic sensor. Therefore, trigger is the output, trigger pin is the output, and echo signal reached to ultrasonic sensor, and that is the input to the sensor input. Pin mode, trigger pin is output, pin mode, echo pin is input. Here some contrast, here are some 16 pins are there here for that LCD, total 16 pins. One contrast pin is also there, contrast. One contrast pin is also there. Already serial begin is indicated, need not write here. Instead of how to vary the contrast of the LCD is an important task by using generally potentiometer. Instead of potentiometer, we use this function analog write sixth pin of that Ardunio board. Digital Ardunio board is connected to contrast pin of that LCD and write some value here, some value. Integer contrast is also defined here, integer contrast. These are the some important declarations in the wired setup. Combination of LCD and serial monitor. For serial monitor, we use serial that begin 9600. Next, coming to void loop actions. This is the trigger pin. This one is the trigger pin. This one is 10 microseconds. You have to define here. This one is the trigger pin is a clear state. Trigger pin is clear state. Digital write. Trigger pin is low. Initially low. Initially low. Delay microseconds. 2 microseconds. Small value. 2 microseconds. This is the 2 microseconds. The digital right trigger pin is low value. Duration is 2 microseconds. After that 2 microseconds, the trigger pin is high. That means digital write trigger pin is high. The duration of the trigger pin is 10 microseconds. That is the reason here we use a delay microseconds. Here delay microsecond, 2 microseconds and 10 microseconds. After that 10 microseconds, 2 microseconds, the trigger pin is low. During the 10 microseconds, the trigger pin is high value. After that 10 microseconds, the trigger pin is low. By using these 4 statements, 1, 2, 3, 4, 5, defined trigger signal. Trigger for generating ultrasonic waves, sound waves. The trigger pin initially the trigger pin is set to high. Next one, 8 pulses are generated. After that here 8 pulses are sound bursts are generated. 8, 1, 2, 3, 4, 5, 6, 7, 8 with the 40 kHz frequency. And also here echo. This one is echo. Find out that duration. This is set at high. This is set high. Duration is equal to pulse information. This is the pulse IN. Pulse IN. This one is echo pin and high. The pulse is at high state. The pulse belongs to echo pin. During that state, the echo signal bounce back to reach to ultrasonic sensor. Next step is find out the distance between the US means ultrasonic sensor and OB means object. Find out this distance. Distance R is equal to, we already explained, velocity of the sound into time. Time means duration. This is the duration. V is 340 meters per second into duration by 2. Duration by 2. 340. 1 meter is equal to 100 centimeters. 1 second is equal to 10 power 6 microseconds. This one is microseconds. This one is centimeters into duration divided by 2. 3 cancel. Here 34 by 10 power 3 means 0.034 by 2. Here centimeters per microseconds. Why is microseconds are used here? Delay in microseconds. Delay is in microseconds. Next, this is the distance in centimeters. Next, distance in 1 inch is equal to 2.5 centimeters. In centimeters is replaced is equal to 1 by 2.5. That means 0.034 by 2 divided by 2.5 gives rise to distance in inches. Distance in inches. Both are indicated here. After that duration, this is the duration of the pulse. Duration of the pulse and find out the distance. In this case here, define the triggering pulse condition. Next, duration of the echo pulse. Here next one. Next, find out the distance between the sensor and the object in centimeters and inches also. Come back to LCD. These distance value in centimeters and inches are indicated on the LCD. Now we have to define LCD functions. LCD set cursor 00, first row and first column. Set the location at which subsequent text written to the LCD will be displayed. Okay. LCD dot print distance. Distance print. You have to display the distance. LCD print distance centimeter. LCD dot print distance in centimeters. This one. Next, LCD print centimeters. LCD dot print distance in centimeters. LCD print centimeter. Next, these are the statements for LCD. These are the statements for serial monitor. Serial monitor. That is, for serial monitor we use serial.println. For LCD, LCD.print. Serial.println line. Serial.print distance. First, distance in centimeters. I will concentrate on distance in centimeters. Serial.print distance in centimeters. Serial.print centimeters. Next, inches. LCD dot set cursor at 01. 0, 1 means 0, second row, first column. In inches means display the distance in inches in second row, first column, and distance in centimeters display first row and first column here. This is the belongs to second row, first column. LCD dot print again distance. LCD dot print distance in centimeters by using this formula, not centimeters, inches. LCD dot print inches, INCH, and the delay 1000, and the delay 1000. Here also you have to inform some after that here delay some 1000 milliseconds. Again we use for serial monitor. This is the serial monitor. These are the for LCD. These are the for LCD. For first column, first row, display distance in centimeters. In the second row, display distance in inches. In serial monitor also display these values. Some delays under delays 1000 milliseconds. This is the explanation of the code. Important explanation of the code. Come back to this one is the ultrasonic sensor, and this one is LCD. For ultrasonic sensor, VCC, trigger, echo, and ground. For ultrasonic sensors, the trigger signal and echo signal is assigned to second and third pins. This one is the second pin. This one is third pin of the digital Arduino board. Come back to this one is these are the 16 pins. These are the 16 pins of that LCD. LCD assigned to 13, 12, 11, 10, 9, 8. These are the pins are assigned to LCD. These are the pins of the Arduino board assigned to LCD. See this one in the next figure. This is the ground. This ground is connected to. Initially, you have to make a ground point and a 5 volts point on that breadboard. This ground is connected to ground point, and VCC is connected to 5 volts. This is the contrast. This one is the contrast pin is connected to already indicated in sixth point. Already indicated analog right. This one is analog right. 6 comma some value. Generally here third pin is the contrast pin. Contrast pin is connected to contrast pin of the LCD is connected to potentiometer wiper. Generally, potentiometer without potentiometer, this contrast pin is connected to one of the pulse width modulation pins of that Arduino board. 3, 5, 6, 9, 10, 11. These are the pulse width modulation pins of that Arduino board. Out of these pins, I choose sixth pin. Therefore, sixth pin of the Arduino board is connected to contrast pin of this LCD. Next one, this one is RS. Register select is connected to 13th pin. 13th pin of the Arduino board. Next, register select is completed. Next one is read write pin is connected to ground. Enable pin is connected to 12th pin of the Arduino board. This one is enable. These are the data pins D0, D1, D2, D3. From the D4, D5, D6, 7. D4 is connected to 11. D5 is connected to 10. D6 is connected to 9. D7 is connected to 8. This is the sixth pin. This is 8, 9, 10. This one is 8th, not this one. This one is 8th. This one is the 6th pin is connected to contrast pin. 13, 13, 12, 11, 10, 9, 8, 8. These are the pins connected to. These are the digital pins of the Arduino board connected to these data pins of the LCD. This one is the LCD anode. LCD cathode is connected to ground. LCD anode is connected to VCC through a resistor. 12th pin. This one is 13, 12. Yellow color is 11. Next one, this one is 9. This one is 8. This one is 6. This one is the 5 volts. 2, 3. 2, 3 are connected to this one is 3. This one is 2. These two are connected to ultrasonic pins. Later will displayed here. This one is a trigger pin. This one is VCC connected to 5 volts. Trigger pin is connected to this one is trigger pin is connected to second pin. And echo pin is connected to 3. Last ground pin is connected to ground. These are the connections between the Arduino board and the LCD and also ultrasonic sensor. These are the this is the object. This is the object. This is the sensor, ultrasonic sensor. And the simulation part, I will show a serial monitor also. By moving the object position from this point to anywhere on that point, the distance are also changes. For first row, the distance is displayed in centimeters. In the second row of that LCD, the distance is displayed in inches. Now we will see the simulation. This one is the simulation. Already these are the VCC, trigger and echo, ground. Trigger and echo pins are of that ultrasonic sensor is connected to second and third pins of the Arduino board. Second and third pins of the Arduino board. Here this one is the 5 volts. 5 volts from that Arduino board, choose 5 volts and make a 5 volts connectivity on the breadboard. And also ground, you choose ground from the Arduino board, make a ground connectivity on the Arduino board. The remaining LCD pins. For contrast, this is the contrast. The contrast pin is connected to the contrast pin of the LCD is connected to 6th pin of that Arduino board. Why 6th pin? Means we must choose pulse width modulation pins. Pulse width modulation pins are 3, 5, 6, 9, 10, 11. Out of that, I choose 6th pin. Okay. Now I will concentrate on simulation part. Code already explained. This one is start simulation. This one is code. Okay. By changing this distance, by changing this one, this value centimeters and inches are also changing. The distance, this is the distance between the distance are also indicated. Serial monitor in that code have indicated both LCD functions as well as the serial monitor functions. This is the explanation regarding ultrasonic sensor. Ultrasonic sensor is used to measure the distance, obstacle distance from the sensor. That is very, very important here. See the start simulation. Code also written, one of that code here. Serial monitor, here also serial monitor. Start simulation. Start simulation. Here 130 centimeters indicated and 50 inches are indicated on the LCD here, and also indicated on serial monitor. If the object distance position changes, the distance between the sensor and the object also changes, and these distances are indicated on the LCD in centimeters and inches, and also indicated on serial monitor in centimeters and inches. With this explanation of that ultrasonic sensor is completed. If you like this video, please subscribe the channel for further updates. Thank you.